So I'm Chuck Willis. This is Willis and Belani. This talk, if you're not in the right place, you're going to know, because the title of this is Web Application, Incident Response, and Forensics. And Rohit really likes the subtitle there, that it's a whole new ballgame. So we're going to be talking a lot about how this is different from your traditional incident response and forensics procedures, and especially the kind of things that we've seen in doing these sort of incident responses. So we'll move on. So we're from Mandiant. This is just a quick overview of our company. We're basically a full spectrum information security company based in Alexandria. We've also got a New York City office. But we do primarily incident response, forensics, application assessments. We have some software, free software right now, so go on our website and grab that. So we kind of do the whole gamut of things. If you guys were in the previous talk, you heard Kevin Mandia, our president, speaking about his experiences in incident response. So that's the one-slide marketing pitch. And now we're going to talk about why we're here. So this is really what we've heard is that you hear lots of people saying that web application attacks are on the rise. Gartner is always doing studies about the different types of attacks that are out there, and a lot of them are not very scientific. It's very hard to quantify, especially when you start looking at exploits and vulnerabilities that are discovered. You'll see a lot of them in the common web applications, but what's very hard to quantify is custom code that always has all sorts of vulnerabilities in it as well. So that's what they say, but what we've seen is that 70% of the intrusions and other incidents that we've responded to at Mandiant in the last year have been some sort of web application related incident. So what we really identified is that our standard forensics and incident response procedures were not working. So we wanted to look at how we could respond to these incidents and how to try to guide you guys along the same, basically the same path. So we will, so that's why we're here. This is the agenda real quick, and I just want to caveat this at first with, we're going to rush through the background and some of the other more detailed slides pretty quickly, because I think you guys are more interested in the actual case studies in that we're going to be talking about. Real incidents that we've responded to that have had details changed in order to protect our clients and all that kind of thing. But we've got just the real world case studies, I think, are what's most interesting. And so, like I said, later on we're going to get to some detailed slides about logs and where different servers store logs. We may rush through those, especially in the interest of time. But those are definitely for your reference to go back to later when you go to respond to an incident. And we're also going to touch a little bit on, once you've done all this stuff, how you actually fix the problem, the remediation that needs to be done. So that's where we're going. And with that being said, I'm glad to see people are still coming in and no one's leaving. So I guess you guys are interested in this stuff. So a couple quick slides on background. The first one is just, this is a web application. So you guys can all see that, right? That's not getting cut off at the sides or anything. You can see the whole slides? Okay, if there's any problems, let me know. But this is a typical web application in the sense that this is kind of the stereotypical model that everyone follows. You've got your client web browser over here that I hopefully can point to. You've got the internet, stuff goes to the internet, HTTP. You've got your web server, that's kind of the front end. You've got an application server that's behind that, and then you've got a database in the very back. And those could be 3 physical servers. They could be all on one server. There could be, especially at the database cluster, there could be a bunch of systems back here at the database level, a cluster of them. At the web server level, sometimes you'll have web server farms and various other stuff in front of the web server, sometimes SSL accelerators and load balancers, that kind of stuff. So that's the one-page web application class. So now we're going to talk a little bit about just the standard incident response and forensics. So this is the stuff that has been taught for a long time as far as how you go about conducting your incident response. And basically, when you come across a system that you think's been compromised, you're going to capture some volatile data, stuff that's going to go away when you shut the system down. You're going to grab process lists, ports, the memory dumps, as far as both the entire physical memory and individual processes sometimes. You want to know who's logged in, that kind of thing. And you may capture some non-volatile data that you just want to have in a more easily accessible form, like the event logs, time, date stamps, that kind of thing. And then after you've done all that, you basically shut the system down, you run it through something like Ncase where you're imaging the entire hard drive, and then you dump that image into the end case analysis portion that will then analyze the system, look at the file timestamps. You're going to be looking for strings in various places. You may check for known malicious software using like antivirus or that kind of thing. So that's kind of the standard incident response and forensics process. So how do web applications differ? Well, that's basically the subject of this talk, but we're going to have kind of a one-page summary here after we talk about why we can't just do what we normally do. Why can't we just go out and do our imaging and all that? Well, unfortunately, as we saw in the earlier slide, web applications are split across different servers. So you've got that to worry about. You can't just image one server. You've got to image 3, perhaps. But the more critical issue is that, especially when you're looking at databases that have huge disk arrays, it takes a long time to image them. And in order to image them, you've got to take them offline. And when you take them offline, the business isn't making money, presuming that that's, the web application is there to support some sort of business process that makes the business money, because normally it wouldn't be there otherwise. So that's an issue. And then you also have the issue of, even if you can do all that and do your traditional forensics, you're not looking for the same things. If you've got a web application intrusion, you're not going to see typically stuff in the event logs or in those kind of places that you look. You're not going to see time and date stamp on files typically as being significant. You're going to be looking for things within the database and within the applications. So that's really what it comes down to. You've got to understand how it is that web applications work and understand web application security issues. And that's what we're here to talk about. So this is really kind of the overview. The very first step is what I just mentioned. You want to understand how the application works and how you can go about, how it normally moves data around and handles sessions and those kind of things. One of the things you're going to be spending a lot of time on is really just looking at log files. You're going to be looking at the web server, application servers, all the other server logs to try to figure out what exactly happened as far as when the system was, when someone came in. And you're going to be basically trying to identify anomalies. And looking at both that and also in the source code is part of it as well that we'll talk about later. And this is the kind of anomalies you're going to be looking for is, typically you're going to have, some sort of malicious input, input filtering that's broken. The application may be logging that. You may have weird referrers or session issues and that kind of thing. So that's basically how it goes. And once you've identified that, then you kind of know, okay, this is how they came in. And then you can basically go back and say, now this is when they came in and what they did, hopefully. And then you can determine your remediation plan as far as what you're going to do about it now. So that's the one slide overview of this talk. So now I'm going to pass it over to Rohit, who's going to talk about a case study from something that we've seen.
Hey, how's it going? So I guess the first case I'm going to talk about is something that we dealt with again earlier this year. You look at the title up there, it says symptoms. And like Kevin mentioned, we rarely go into an organization and where we're told exactly what happened. We wouldn't be there if that was the case. So when we walked in, we're not told, and sir, I'm suffering from mononucleosis due to streptococcus bacteria in my pharynx. That doesn't happen. It's more something like I got a throat ache. We have to kind of figure out what happened from there. So if you look up the slide there, this is the symptom that we walked into. All we were told is, I saw a trade executed from my account. 10,000 shares of a company I've never heard of were actually purchased using my bank, or rather my brokerage account. It happened on January 17th at approximately 2 p.m. is what the alerts show me in my online profile, and that's all about I know. Well, 7 other clients of that brokerage firm, people like you and me who use web-based brokerage firms, reported the exact same incident. So 8 people were reporting the incident. Anyone want to tell me what the cause might be here just looking at this particular scenario? Well, these guys are home-based users. They're all probably different people. But one point was right. It probably was a keystroke logger. That's the first thing that comes to mind when an end user's hacked. Chuck's ready with the T-shirt. He's a bad thrower. Oh, God.
Almost made it.
So 8 people reported this incident. What was interesting, and I'll give away the story before I even get into it, there were thousands more who were affected by this exact same incident. But none of the other guys reported it. Why? I'm sorry? Embarrassment. Didn't notice it. Oh, who said that? That was the answer. I got to come and give you a personal invitation to our cocktail party. You are great. The stock went up was what the reason was. So the stock goes up, people make money out of these trades. Obviously, they're not going to report it to the authorities. Make hay while the sun shines. So we walk into this scenario. Well, obviously coming in as computer experts, we look at two different aspects. It could be the web application or the infrastructure at the brokerage firm that might have been hacked, or it could be the end users, keystroke loggers, other forms of malware that are on the system. We didn't know what was going on. All we knew was 17th January 2006 at approximately 2 p.m. something happened. Shit happened. That being said, we kind of split our team up into two and said, well, you guys go look at the infrastructure for the brokerage firm, and you guys go look at the end user machines. So the guys who started looking at the end user systems were obviously looking for malware, but the other guys had to understand how the web application operated, what possible logs they could get their hands on, network logs, firewall logs, etc., etc. It was a long process. As part of the process, we received IIS logs for 17 January 2006 from all the load balance servers. You can imagine on a brokerage firm, those log sizes can be pretty large, especially trades around 9 a.m. in the morning, 9:30 a.m. in the morning, 4 p.m. fill those logs up pretty quick. We came out with 1 gig of log files. There was no easy way to manually look through them. Fortunately, in this case, a Microsoft software came to the rescue, Log Parser. Log Parser, just to give you a little bit of background, is a pretty good tool to analyze log files, especially if they're Microsoft log files. And it allows you to use SQL syntax to actually peruse these files pretty easily and trim them down to sizes that are more manageable. So what did we want to do first? Actually, let me go back and ask the question. For those with keen observation powers who looked at that slide for 1.5 seconds, what would you want to look for when you walked into this scenario? If you were the guy looking at the brokerage firm's infrastructure and application, all we knew was malicious trades were executed on a particular day at a particular time. I'm sorry? Internal attack. But okay, let me rephrase. From the particular date, the particular time. Look for the particular date, particular time. Definitely want to do that, yes. And the stock. And the stock. Right. If it was a part of the get parameter, if it was a get parameter that was passed as a part of the URL, we definitely want to look through the log file looking for that particular ticker symbol. But even before that, we said, well, let's just look at all the executions that happened, all the trade executions that happened on that particular day around that time. So we ran a query using log parser, said, let's just select all execute.asp requests that happened on that particular day and dump them in a CSV file that allows us to sort it pretty easily using Excel. Having done that, obviously, we had an overwhelming number of responses that came back. Here's an abridged version of the log file. Again, it's been sanitized for obvious reasons. What you see there is not nearly as detailed as what we were having to deal with. But now start my barrage of questions. Having looked at that, help me solve this case. What do you think is the problem here? Can everyone read the... Ooh, I heard session IDs, times, yada. Source IPs are related. So you see that one particular source IP address repeated several times. Someone said session ID. Who was that? Session IDs. What about the session IDs? The session IDs are the same. Anything else you see there? I'm sorry? Different IPs using same session ID. Is that accurate?
Yes.
Yes, that is accurate, actually. What else do you see there? HTTP version 1. Good observation. Anything related to the timestamps that's interesting? Every 5 minutes I heard someone say that. So what you see is the same IP address posts something to execute.asp with the same session ID every 5 minutes to the T, except for one of those cases, I guess, where there was some sort of a network delay. It led to a 1 second lag. What does this tell us about this attack? It's automated. It's probably an automated attack that's occurring. Someone's written a script to keep posting to execute.asp with a particular session ID.
I got a question.
Yes.
Well, this attack, so you're making a whole bunch of people buy software. Why? Just to prove that you can do it?
It's a pump and dump. They're trying to, they've bought stock before they started the attack at a low price. They make all these other people buy the stock, bring the price up, and then they sell it.
Yeah, that was a great question. Why were they buying stock using other people's accounts? Like Chuck said, they were artificially inflating the price of this penny stock and were ready to sell it. So the other 983 folks who didn't report it were going to have a good time. So what we saw was there was multiple requests for execute.asp occurring approximately every 5 minutes from the same IP address using HTTP version 1.0. So after we noticed that, we said, well, let's pass out all requests with that particular suspicious session ID. Well, you don't see the same session ID occurring every 5 minutes. There seemed to be something wrong with that. So there you see the log parser query saying, well, that particular session ID in the URI query, show me every single one of those requests from the web server logs. And here's what we found. Looks pretty similar to the previous one. But what do we see there? Change an IP address. Interesting. So we see another IP address now using that same session ID. What else do we see? I'm sorry? Login. We see requests to login.asp. It's not just execute.asp. After login, there's access to account.asp, execute.asp, and then confirm.asp, kind of what seemed to be a logical flow of executing a trade. So what was interesting here was it seemed like someone from this particular IP address, which is the 22.33, again, a fictitious IP address, kept pinging the application every 5 minutes in an automated fashion, trying to get in there. Something gave way when you see this particular .33 IP address actually get to the confirm.asp page, confirming for us that he was actually able to execute the trade. What gave way? I'm sorry? ID and password. Well, why didn't he use it at 1:03 in the morning if he knew the ID and password? The user was logged in. Who said the user was logged in? You deserve another personal invitation from me. You say that? The user was logged in. So what appears?
Okay.
So what appears to have happened there is someone coming from a different IP address logged into this application at approximately 2:07 in the afternoon. Following which, you see that the malicious IP address, the .33, was able to go on from execute.asp to confirm.asp. So the attacker almost seemed like he was waiting for someone to log in with this particular session ID. The moment that happened, he was in. How would you classify this attack? I hear session fixation resounding in this hall. That is right, it is session fixation. But what is interesting is, why did it take that long? What happened? How did this guy guess a valid session ID to the application? You look at that session ID there, it's damn 32 characters long with random numbers and digits and whatever else in there. I'm sorry? He waited for it to repeat. That was my initial thought as well. He probably waited for it to repeat, but that would have been kind of a longish attack given the character space that these session IDs actually go through before they repeat. What else could have been the reason? Predictable, stole it. It could have been any of those. He knew the algorithm, which would have been a smart attacker, but he wasn't that smart. I'm sorry? I wish you were on my team when we were responding to this incident because the dumb guys couldn't guess that for 48 hours. Oops, sorry.
Oh.
The answer was the application actually handed out the session ID before you logged in. So you hit the application said, okay, sir, here's your session ID. After you log in, we will repeat the same session ID and activate your session with it. Yes? That's correct. He didn't have it from a previous login. All he had it from was just hitting the application, unauthenticated, getting this particular cookie/session ID and saying, well, now I'm going to reuse this and try to have someone activate their session with this particular session ID.
Yeah, we're going to get to how the victim got the session ID. I think that's what you're getting at.
Yeah, the big question was, how did he force someone to use this session ID? And we were still stumped at that point. Well, now comes in the team who was actually looking at the host of the victim, the end user machine of the person who we thought might have been compromised by a keystroke logger. We started looking at the machine. There was no evidence of keylogging Trojans, no malware, viruses. It was a pristine machine. But what we found was an interesting archive.pst file. For those of you who don't know that, it's the archived inbox out of Microsoft Outlook. We found an interesting email in there. An interesting email was from customer service of this particular brokerage firm. At first, if any of us looked at it, it would not have appeared to be a phishing email. It did not have typos. The grammar was good. It did not appear to be a phishing email. But like all of us know pretty well, we don't click on these emails. So when we interviewed this end user, we asked him if he clicked on the email. He was actually offended when I asked him that question. And he was offended because he thought he was pretty techno-savvy and said, I know better than that, but in this case, I did click on it. And I said, well, if you know better than that, why the hell did you click on it?
Well, in the user's defense, I mean, that does look legitimate. It's going to the real brokerage. It's going over HTTPS.
Exactly, and that was the reason he gave me. If you look at the URL, I've expanded it down there. Well, the click here URL that we looked at was actually going to the brokeragefirm.com/login.asp. It wasn't a random IP address going somewhere to Eastern Europe or somewhere in the Pacific Ring. It was going to the brokerage firm. All it had was an appended session ID to it. And guess which session ID that was? The one the attacker had already got by hitting the application, and it gave it to him prior to login. So the pieces of the puzzle kind of came together. It was a combination of social engineering and poor application design that led to this attack. People were able to conduct session fixation attacks. So just as a summary, you guys already picked it. It was session fixation. Session ID was issued before login, and he was able to successfully social engineer a couple of people at least to click on that link, activate their session IDs, and thus get into the application, execute these false malicious trades. Any questions on this case? How did he get email addresses? Very interesting question. We did not have time to investigate that, but our suspicion was when we looked at the application, there was an interface on a particular page that accessed end user data, and that was susceptible to SQL injection. So we thought it was a SQL injection attack hitting a completely different database that had email addresses in it as well. Any other questions?
Where did you detect the source of the attack from? Was it overseas, US-based? Where did you determine it came from?
It was overseas, and we'll leave it at that.
So the application was built such that even though it was issuing you the session ID, it would accept the user input session ID. That just doesn't make any sense. That's basically what you're telling me. Is I pass through the URL, and I tell you what session ID I want to use. The application will accept that.
And you will be surprised to know almost every application we assess, especially ones which use JSession IDs, are vulnerable to this attack.
Yeah, but part of the problem with this is that they were rolling their own session management. They weren't using the standard ASP.NET session stuff, and that was part of the problem that led to this.
Right. But if you look at a lot of the JSP-based applications, they are susceptible to this sort of an attack. Even though the JSession ID is an extremely random, strong session ID, they are susceptible to session fixation. Okay, so I'm going to pass it back to boring Chuck.
Yeah, I get all the boring slides, but like I said, we're going to go through these quickly because they're not near as much fun as Rohit's stuff. So we talked a lot in that case study about logs, so I just wanted to put some slides in here, like I said, mostly for your reference about where the logs are in a typical web application. IIS, at least 6.0, they're going to be in the underneath your log files directory, and they are easily parsed with your log parser, or you can even just open them up in text editor. That's fine. And we're going to talk a little bit more in detail about what they do capture by default, which is basically what we were seeing in the slide earlier. They were just using basically the default logging. So you're going to know the date and time of accesses, your client IP, server info as far as the IP of the server, the host name of it, and then the method used, URL and parameters, status code, user agent. So that's useful. There's a couple other things you might want to add. You can actually log transfer sizes, which is useful if you're trying to see what kind of data people are pulling back, especially if you see a lot of times automated attacks are going to be looking at the sizes of the responses in order to detect if something was successful or not. And then you can log cookies in the referrer header as well. And unfortunately, you cannot log with IIS 6 any of the post data, so the data that's inside the post, the body of a post request. Some would call that a feature because post data is supposed to be kind of sensitive and not logged by proxies and that in between the client and the server. But for the server, it's important, and we're going to talk more about that in a second as well.
Actually, before Chuck even moves on, why do you think the post data is important? And actually, I think that's the next slide. But
well, I just showed it to him. But.
Right. Let me. Yeah. Why do you think the post data is important? Yes.
All your SQL insertion attacks are going to be in the post data.
Exactly. Great answer. The fact is that a lot of your SQL injection attacks, cross-site scripting attacks, etc., might target parameters that are passed via post to the application. You won't see any of those in your web server logs. And how often do we see applications actually logging violations to input validation? Who's seen that? Oh, my application logs a potential SQL injection attack. I've never come across that. So basically what you're saying is you lose all this important data by not even providing the option to log post parameters.
Yeah, if there's any Microsoft people here, then we're expecting that to be fixed in IIS 7. Take that as a task.
Why wouldn't it be a governance issue, though? So if you have a post, right, that it could contain PII or DHI, then it may not be able to be tracked in certain governance.
Well, it's one of those things you should give the server administrator the option. I mean, there are certainly, and it should probably be on a per-page basis. Especially like login pages, you may not want to log the post parameters because it's going to have the username and password that then you got to keep track of who has access to that. But in general, there's a lot more to be gained by it than to be lost by it. And a lot of it comes down to you secure your logs properly. You make sure that only the right people have access to the logs, then it's not as big of a deal. But yeah, there's certainly issues. It shouldn't be something that IIS just does on its own automatically. It's like, but you should be able to configure it. It'd be nice to at least have the option.
Yeah, and actually it helps in when you're really asked the question by executive management to perform a damage assessment. What was taken by the attacker? There is no right answer if I cannot see what was carried in the post data. All I can tell you is from the get parameters, yes, it was a SQL injection against some parameters passed via get, and potentially 13,000 credit card numbers were compromised from this table, but I have no idea what happened beyond that.
Yeah, that's the key there is that, yeah, being able to go back and figure out exactly what happened as far as that. So that's why we care about post data, and Rohit's going to talk a little bit about why we care about cookies.
So going back to another case study, in May of 2006, we were actually contracted by a multinational food and beverages company. They had put out a tender of sorts, a contract out there, and they had an online system to accept bids from different contractors. There was someone raised the suspicion that there might be a particular contractor who knew the bids of others and was able to cut them out of competition. We were brought in to kind of investigate that from a computer security standpoint. The chief counsel was all worried at that point. In this case, actually, they did have the cookies logged in IIS 6, which really helped us solve the case. Had that not been the case, there was no way for us to do that. Because what we observed is we perused through the IIS 6 logs and we found the same IP address. And when we who is that, it was one of the contractors, was basically accessing the bid.aspx page, and the cookie was different across all those different requests. The cookie that was different was a user ID cookie. And so what he was able to do was it was an application that had poor authorization mechanisms. It relied on a simple user ID cookie, which was a 3-digit number. And once you could manipulate that, you looked at other people's bids, and obviously he was able to undercut them. So in this case, actually, the fact that IIS 6 allowed cookies to be logged really assisted us in this investigation. Moving on, the referrer header. I've always seen a lot of speculation as to whether it's a good thing to look at the referrer header, whether it's a bad thing, whether it's a misleading header, or it's actually something that's useful from a forensic standpoint. How many people think that the referrer header is useful from a forensic standpoint? I see very few hands going up. And how many think that it's not? Because I don't assume the others who didn't put their hands up do think that way. See, the others are no comments. Okay, so about 6 people think that it's useful and 3 thought it's not useful. Well, the answer, I don't know. There's no right answer, and I kind of wanted to get your opinion on it, because the fact of the matter is, by looking at the referrer header, you could actually identify potential anomalies in the workflow of the application. So if someone jumped straight to the execute.asp page like we saw in the first case, that might have been detected had the referrer header not been the login.asp or one of the previous pages. But what you also have to keep in mind at the same time is that referrer headers can be fairly easily spoofed. And so if that's the mechanism you're relying on to understand how your application was broken into, you could be misled down the wrong path. So it's kind of a catch-22 situation. It's probably worth it to log it, have a look at it, but don't rely on it completely.
Yeah, I think that's the key, is when you're looking at like a cross-site request forgery or a cross-site scripting kind of attack, the referrer can be an indicator of, yeah, why is the victim coming from some other strange location? But yeah, when you're looking at something where the attacker is just beating on your application himself, he can make the referrer header say whatever he wants. So there's really nothing you can do about that. And also keep in mind, some people like to use referrer headers for session tracking, and that's not good either, because some browsers, like Opera, I think, doesn't even send a referrer header by default. There's Firefox plugins to disable referrers along with IE proxies you can use. So you can't really trust it. But it can be useful. You know, it doesn't hurt to have it and look at it as long as you don't put too much faith in it.
And then we'll just touch real briefly on URL scan. I guess it's really a defunct after IS6 is out, because they don't even recommend running URL scan, because a lot of the functionality is already implemented in IS6. However, previous versions of IIS did not have this functionality in there to block requests that exceeded a particular length, had potentially malicious characters in them. So a lot of website administrators ran URL scan, and that was a pretty good source. The log files were a good source of identifying attacks. At least Nikto scans, it kind of picked those up pretty well, if nothing else. So I just wanted to touch on that. It's probably not even valid once a lot of the people have IS version 6 or higher running. And I'll pass it right back to Chuck.
Yeah. Just going to go real quickly over Apache. I mean, basically, Apache logs the same, roughly the same stuff as IIS by default. It does seem to have more configuration options with whether stuff that you can log. But the key really in any of this logging, especially when we get into the application servers, we're going to move really quickly, is it's a matter of, we want to make sure that you guys have some familiarity with what can be logged, and then just know the right questions to ask the system administrators. Because a lot of times the system administrators may not even realize that some of these things are being logged. So if you just point them in the right direction, then that can be helpful. And, but otherwise, typically they are going to know, hey, this is all the log files that I have to rotate every month or whatever. So they're going to know what it is. So as long as you ask them for it. That's the key, really, is when you're responding to the incident initially, you need to get all those log files right away, because some of them get overwritten pretty quickly. So with Apache, I kind of just mentioned that. The two main ones are the access log and the error log. The access log is really what's going to have the HTTP request, which is similar to what you saw in the IIS logs. Error log is more if Apache has errors, you'll see stuff. The file names are a little different on Windows or Unix. And some modules, especially mod rewrite, if you're using that, has its own log that can be useful for perusing as well. So this is the default log format line that you'll see in your httpd.conf. Basically, it's logging those things. It's pretty much, like I said, the same thing that we saw there. You do get the number of bytes by default in Apache, which is kind of nice. It even tries to use identd, which is kind of surprising that it still tries that, but typically that's going to be nothing there. And mod log config is what will basically allow you to do a lot more of the configuration of your logging. And it does have the option, I believe, to do your post parameters where you can capture those as well. It's just we haven't seen it actually being used, unfortunately. So that's a quick and dirty over Apache. So now I'm going to talk for a few slides here just on different application servers. So we're moving back, basically, if you remember back to that original diagram, we've talked about the web server, which is typically what's handling the initial SSL negotiation and requests from the client. And now we're to the application server. So it's what's really doing the dynamic content as far as building pages and that kind of thing. The web server will handle like images and style sheets and some of that kind of stuff. Application server is what's really building the dynamic content of the application. So the applications will log various data. The application server itself doesn't log a whole lot because there's not a whole lot that it can log. I mean, it doesn't connect to the user, so it doesn't really have that kind of information at that level. Especially like if something like HTTP authentication is being used, that's handled typically at the web server level. And if typical, more like form authentication is being used, that's handled at the application itself. So it's kind of in the middle, but it does have the ability to log basically things that the application didn't take care of. So if the application throws an exception that doesn't get caught anywhere, then that will get logged by the application server. If there's any sort of loader problems where a class is referenced that isn't available, that'll get logged by the application server. And some other implementation dependent stuff. The application server also handles basically redirecting the standard output and standard error of the application to log files that then you can look at later. So the application server, we're going to go through a couple examples, is basically, it's off-the-shelf software. So ASP.NET is, of course, the most common one. It doesn't have its own log files, where it'll basically throw stuff into the Windows event logs. And one of the interesting things is .NET 2.0, it will actually halt the application if there's an exception that's not handled. So that's a good thing, I guess, in the sense of it, when you're in QA and those kind of things, it's good to detect those bugs early rather than try to muddle on through it. But of course, it is a potential denial of service in that sense. It'll restart the application, but it just takes a while. So WebLogic is the most common Java application server that we see, and it has a variety of logs. I'm not going to read through all these slides. Like I said, these are more for your reference, but it's logging basic stuff from the application server level, at least, not from the application itself. And it also has kind of its own Apache, kind of modified Apache build that it's included with it, and it has a lot of administrative stuff. And there's also a lot of kind of miscellaneous stuff that may be added if you're using some of the other Java transaction and database stuff that might be there. And as I mentioned before, your standard output, anything the application writes to standard output will get redirected. And WebSphere does essentially exactly the same thing, it just puts them in different places. So that's basically how that goes. And unless anyone has any questions on that, like I said, we're moving quickly through the dry slides so we can get to the more interesting stuff. So I'm going to pass it back over to Rohit to go through another little case study.
Okay, I'm back.
How are we doing on time, by the way? We got till half after, right?
That's right.
So
I want to leave about 15 minutes for questions.
Yeah, we're doing okay, but.
So this is another case that we dealt with where a CEO of a retail organization received an extortion threat. This is fairly common these days, requesting $250,000, and the threat was the fact that the attacker potentially had about 125,000 customer credit card numbers for that retail organization. How would you respond at that point? What did you think the CEO wanted to do? You want to make the payment, right? Yes. You wouldn't make the payment. We have a Boy Scout there. Right. Sure. So there's definitely people who wouldn't make the payment and who would make the payment. There's a lot of factors that go into that decision. I guess, business factors overplaying technical excitement of actually investigating the case. But in this particular scenario, we had some pretty seasoned negotiators involved who were able to buy some time from these extorters, a mere 72 hours. We were called in to perform a quick and dirty forensics assessment, if you may will, to try and determine if there's a way to figure out who it is and to stall it in those 72 hours. So our job was to kind of figure out how the credit card database might have been compromised if it was a computer security breach, and if there was a way to determine who the attacker was. That's an interesting question. How did we know that they had the actual credit card numbers? In the snail mail that was actually received, they had an excerpt from the database. That kind of indicated that they did have valid credit card numbers in there. They could have been obtained any which way. We were just in there to see, was there a way that they could have, was it phishing, was it SQL injection? We didn't know at that point how those credit card numbers were compromised. But the fact that they said it was 125,000, we had initial doubts that actually 125,000 people fell for such a phishing attack. Shouldn't we report that to law enforcement? I'll leave that as an open question. How many people think that should be reported to law enforcement? Right. So here's an interesting point. Some states require you to do that. Others do not. It depends on where the company is based out of. When it's based out of the Bahamas, it's kind of hard to enforce any such laws on them. I'm sorry? Right, and then there's the gray issue of, some people might say it's only a thread. We got an excerpt of 6 valid credit card numbers in there. Was it a phishing attack that actually targeted end users and not their systems? Is it their responsibility? There were a lot of gray areas in the legal issues. To be frank, at that point, given that we had 72 hours, we kind of stayed out of that and said, we're going to go ahead with what we're tasked out here for, is to determine from a technical standpoint how they might have been compromised. Yes? Absolutely, that was definitely a part of the decision. That was definitely a part of the process was, yes? That's right. There's definitely a lot of factors that go into making such decisions, and I'm just reiterating, we walked in there, we said, okay, we're tasked out, we're overwhelmed, 72 hours, we're just going to keep going at this application, keep looking at all your infrastructure, you guys deal with the legal issues, they had a whole legal team taking care of that. So actually what we did is, we did what's up on that slide. We performed some frenzied web server log analysis, like I said, looking for attacks like I talked about prior to that, looking for SQL injection type of attacks. Again, the fact that there was no post data logged in there, it was kind of hard for us to say whether SQL injection might have occurred or not. We didn't see any evidence of that being performed. We also looked at employee emails, went through those, scripted up stuff to see if there was an insider who was leaking out these credit card numbers. Just looking at it very briefly did not reveal any such activity. We then said, well, let's look at database server logs. We asked the database administrator, do you log anything on your database? He said, I run Microsoft SQL and I have full logging turned on. Well, full logging turned on meant that login and logout activity were logged. That didn't really help us because all we saw was logins from the application server hitting the backend database. So it really didn't help us there at all. We then went on to say, okay, well, we just had to kind of, it was a shot in the dark. We said, it seemed like from our past experiences that it looks like it might have been a SQL injection kind of an attack given the magnitude. Let's just try and scan this application real quick with some sort of automated scripts to figure out if it's susceptible to SQL injection. No luck. So at this point, the last resort was, I want to look at that source code quick and dirty. Obviously, there's millions of, or I guess thousands of lines of source code. It's not possible to go through it in a comprehensive manner in 72 hours. But that was our last resort. Let's have a quick and dirty look at the source code. So a comprehensive code review was obviously ruled out. We were up against a time bomb. And we resorted to some sort of scripted searches looking for some basic vulnerabilities in there. So since I said that SQL injection was what we thought it was, we said, well, let's look for all select queries in the source code. So we created a regular expression that you see up there and ran the equivalent of grep searches through the source code base, trying to identify all places in the application code base where a raw SQL query was embedded, where there was no stored procedure call, but an actual select query was in place. Anyone want to guess what the results were? It's up there, overwhelming.
Overwhelming.
They were literally t-shirt. Okay, sure. That answer deserves a t-shirt. Overwhelming. Who said t-shirt? Okay, I'm going to ask you guys to pass it back on to him. So, given the fact that we had an overwhelming number of hits for select kind of queries, we already knew that this application didn't really follow best practices in accessing the backend database. But then we said, well, let's make our search a little more granular. Let's look for select star kind of queries, the kind of queries which are possibly most susceptible to such attacks because they yield the most information. They yield every single column of the database. So we ran that, and we found exactly 5 hits. So that was pretty good, overwhelming to 5. From those 5, we started looking at them, and what we found was one was select star from card table. Obviously, I changed the name of the table there. But it was a select star query which accessed the credit card database. We actually went to the line in code there, which was ASP code, and we looked at it. Now, I am definitely going to give away a t-shirt and a ping pong ball to someone who tells me what's going on here. Come on. Someone read the slides on the CD already. No, kidding. Right. Now that's a good answer. I'm going to request you guys to pass this back to him. I'm going to see how far I can throw the ping pong ball. Got it pretty good. So he picked it right. It was a developer backdoor. If you look at that code there, what it does is it looks for a parameter which it terms as extra, which was already a giveaway. So what it was looking at was the URL, pulling out all the parameters from the URL, and there was one additional parameter, the fifth parameter, and if the fifth parameter's value was equal to let me in, then well, do a select star query and actually display the results of that back to the end user. So it definitely seemed like an insider job. Someone created this additional parameter so they could keep coming back and viewing what was going on. Now, was it an insider job? We started talking to the guys and we figured, well, they had outsourced much of their application development to some third party in Asia.
We'll let you guess which country.
No, it wasn't India. So we started looking at the code archives to detect addition of this particular code. We wanted to look at the different version numbers that were actually checked in to identify which particular version had this piece of code and who had checked it in. We went through that. We were lucky we found the user ID that was used, but it was a generic user ID that was used by this third-party provider. Well, now that we had this information, we went back to the web server logs and said, well, on first attempts to look at it, we didn't see any SQL injection, we didn't see any of that. But what we know is that if we find this fifth parameter in one of the requests, there is something fishy happening there. So we actually used log parser once again to pretty good effect, identified all the requests that had this additional parameter in them. Guess what? It came from an IP address in Asia, the same country. It could well have been a proxied session, but the fact that we found that the developer from that country, and then we see an IP address from the same country accessing that fifth parameter, he wasn't probably smart enough to proxy through a proxy in the United States, maybe. Exactly. That's what I want to tell him.
Yeah, the big thing. Yeah, the big thing in this case really was the check-in, the being able to trace it back to the development company, and they were able to kind of know who had been working on the code at that time and figured it out for the most part from that. I mean, it definitely gave us some more just to be able to kind of convince the management at that company that it was them when we had the IP address.
Yes.
That wasn't this case. That was the previous case study.
No, he was talking about the snail mail. We'll discuss that offline. But the fact of the matter was, again, we thought about the proxy case, but what happened here was just given the country this person was coming from, he probably did not care if his IP address was shown in the web server logs. He knew there was no way to get a hold of him or her. He was proved to be wrong because the development company was notified of this rogue activity. The law enforcement, local law enforcement was roped in. And believe you me, they were actually cooperative in this case. They actually did get a hold of the person. Yes, so we were actually able to successfully halt this attack. And actually, law enforcement was from the US side as well involved in this, just to go back to your question there. Just didn't want to give it away right now. Because there was no way we could have got cooperation from local law enforcement in that foreign nation without their help. Yes?
That's above our pay level.
Yeah, all I'm going to say is that wasn't my decision to make. Yeah. I was lucky.
When was U.S. law enforcement involved?
They were involved pretty early on in the case, but late enough that it allowed us to perform some initial forensics by ourselves. We walked out of the case. We don't know what happened. Oh, we were actually getting pretty close to the 72 hours, but we were actually able to understand this attack prior to that. And like I said, because local law enforcement was cooperative, we were able to prevent this attack from taking place. Otherwise, you'd have seen it in the news. Not to say that you've not seen 15 other similar attacks. It might have been one of those. They made initial contact via snail mail to kind of prevent detection via electronic means. They did not want to send emails and have them traced back. What was interesting, I guess I missed it on one of the previous slides, was they said if you are agreeable to our terms or not, you need to specify that on the main web page in small font right at the bottom. So what another technique would have been, had the 72 hours lapsed, we would have monitored every single IP address potentially hitting the main page. But given the fact that it was a large retail organization, there's millions of IP addresses that hit this page. So I guess going into the post-mortem, what could have been done better? And there's a lot of different answers. That's definitely not a comprehensive list up there. Some of the things that could have been done better was if there was encryption of sensitive information. This is what I was telling Chuck yesterday, but he disagreed with a valid point, saying the fact that if there had to be a way to decrypt it, and if it was a developer insider job, he probably knew what algorithm, what key was being used to encrypt it, so he could have decrypted it as well. So in this case, probably it wouldn't have held true, but definitely encrypting cardholder data, which is now a requirement by the PCI, Visa guys, definitely that was that would have been one of the countermeasures in normal circumstances. More advanced database logging, that complete database logging didn't really help us. The login, logout activity. Anyone have any suggestions as to how that can be enhanced? How can you enhance database logging on a Microsoft SQL server? Use a third-party tool. Is there any other way to do it without me having to spend money after I've already drained my pockets out on Microsoft? I heard triggers. Stored procedures, triggers, server-side traces. Sure. Very valid point. How could you do it without impacting the performance of the database? And just hold on, we'll discuss this in the next couple of slides as to what the different options are. A lot of the security folks would have walked in and said, C2 auditing is your answer. I disagree on that because it would impact performance to a level where the retail organization might as well not do e-commerce. But also one of the other yes?
Well, the one thing that I've seen is there was a select all query to the card table, and I would think that type of request from the application shouldn't be a valid request.
Right.
Why would you want an outside query to your entire table where you're sensitive?
That's a good point he brings up. Why would you want a select star kind of query? That should kind of light up the alerts as well. And that's exactly the third bullet point there. If there was comprehensive code review there performed from a security standpoint, they would have caught those select star queries and said, this does not look legitimate. Or even if it were legitimate, this is not best practices. So from that standpoint, I thought in this case, a combination of reviewing the source code as well as performing a little more advanced database logging just rather than login, logout activity would definitely have helped to prevent the attack. Yes?
Did you review their other applications for similar issues?
Well, yeah, we kept ourselves busy for a while. I'll leave it at that.
How would your encryption of the database work when more than likely the application request would be valid and it would be encrypted?
That's right. That's exactly the point I brought up. In this case, probably encrypting the sensitive information would not have helped since it was almost a backdoor within the code. A developer would have known the algorithm and the key to decrypt the information. I'm sorry? I did actually modify the code to make it a little more obvious. The value of the parameter was not let me in, and that's the reason we were kind of banging our heads against the wall trying to figure out what was happening. Yes. That's correct as well. It would have worked if that was the case, if they didn't really need to, yeah, exactly. Oh, absolutely. That's always an option these days. They fell off the truck, some consultant walked in, made a copy on his laptop, his laptop got stolen, lost his laptop. Those are very viable options. Yes?
Have you also tried looking at the parsers and developing, so you do a lot of incident
Right.
response, and you might start to see a repeat of the same type of attack.
Right.
Would you link your parser with something that would say, I'm looking for these known type of events?
Yeah, I actually have, I'm in the process of converting it to a batch script right now, just for the fact that I don't really have time to make it fancy. But I've come up with the regular expressions to look through ASP source code at this point, which kind of identify flaws similar to this, or even not backdoors, just poor practices related to session management or SQL injection, or cross-site scripting, etc. And we can definitely talk about that. So, security reviews of code would have helped, advanced database logging. The one I'm going to discuss here a little bit right now is what the options from a database logging perspective were. Like I said, the common databases by default really do not enable much logging, and for a valid reason, because it hits performance pretty badly. And most of them have, especially Microsoft SQL Server has the all or nothing option. Most of the time people are like, is it C2 or is it just log in, log out? And like I said, a lot of people will say, well, let's do, C2 auditing is the way to go. And there are some advantages to it for sure. The fact that it records a whole bunch of information, if there is a potential attack, there is a high probability, definitely higher than the default Microsoft SQL Server logging enabled, that you will detect the attack if you have C2 logging turned on. These logs are normally stored in tracefiles.trc files, which fill up, and once they're 200 megs in size, it creates a new file, I believe. So they can be viewed by using SQL Server Profiler, and there's a lot of people out there who say that's the way to go. Like I said, it has a bunch of disadvantages which from a business standpoint don't make any sense to enable it. Performance is hit. If it stores stuff in the same directory or the same disk as the SQL Server is resident on, if the disk gets full, the SQL Server stops responding, which is a requirement of C2. It's a fail-safe requirement. You definitely don't want that in a commercial environment. So what I've used C2 auditing as, it's not a practical long-term auditing solution, but what I've seen it used effectively for is as a short-term option when responding to an ongoing incident. When you know that there is an ongoing incident, it might not be a bad option to enable it just to detect the nature of the attack at that point in time. And it has seemed to work in the past, because that's where you really try to find the SQL injection kind of attacks, or if there's a malicious backdoor stored procedure, which we've run across in the past, which was not as easy to detect.
Got a question over there?
Yes.
Not for C2 auditing.
No.
No. Oracle, I believe, has some of those kind of things where you can send stuff to the operating system log that then can get sent to the syslog to other places. But
no, it does not actually. It does log it specifically to the same directory where your SQL Server is resident. Actually, so before I pass that on, okay, I guess it's Chuck's turn again to speak.
Yeah, I'll just talk real quick about Oracle. I mean, it's basically, by default, it's the same kind of things you see in Microsoft SQL. It's logging when the database starts, when it stops, and connections to the database, which in a web application is just going to be basically connections by the application, whatever usually the application is running as. You'll also see DBAs connecting. But by default, that doesn't tell you very much useful. But it does have the ability, you can audit some additional events, either to a table in the database itself, which is handy because then you can run SQL queries on it and whatnot, or you can send it to the operating system log, which then can get redirected with syslog to another system or wherever. And those events, so the top events here are what's called mandatory auditing that you really don't have any control over in Oracle. And then the bottom is just kind of the Oracle auditing, they call it sometimes, or I call it additional auditing of other things. And you can do table level access in the Oracle auditing, but you can't get down to like row level access that you can audit. And just a quick terminology, and I don't want to belabor the point, but I think it's important for you to know kind of what this means. Is Oracle calls all this stuff auditing, where in reality it's not auditing, it's really logging. But logging in Oracle means something entirely different. Oracle logging is basically how Oracle kind of checkpoints the database to be able to restore from a crash. So if you're talking about Oracle logging to Oracle DBAs, then that's what they're talking about. This is auditing that they're talking about here. And then you also run into, in addition to auditing, it's got alerting, which is, at least that's what I call it. It's the alert.log file, which basically is going to record some database type operations as far as if there's errors in stored procedures, if there's references to things that don't exist, that kind of thing. And it, It also will have trace files and dump files that it basically, the main alert.log will point to these other files. So that can definitely be useful, just like the Microsoft SQL error log can be useful in finding like SQL injection attacks especially, because SQL injection attacks typically, it takes a while before the attacker quite gets it right. So he causes a lot of SQL Server errors in the interim. So that's just a quick down and dirty on Oracle auditing. We got 15 minutes left, so I'm going to run quickly into application level logging. And I don't want to run through this too quick because I think this is very important. And if we had a room full of developers, we'd spend a lot more time on this. But in general, the application is the best place for the logging to happen. The application knows the business logic of what's going on. It knows what users are associated with what sessions, all that kind of stuff. So good application logs have a very good signal-to-noise ratio in as far as telling you exactly what's going on in the application and potentially where there are problems. So when you come into a web application incident, you want to ask the developers or the administrators, hopefully you can talk to both of them, is where does it log this data and what kind of format does it send it in? Is it a text file or is it going back to the OS log or what? And what kind of messages are you going to see in those logs as far as things when you start doing your greps through the logs, what to look for? And also it's important to know how long they're stored because it's, they may be overwritten pretty quickly, so you want to make sure you grab them right away. So application level logging is great when it's there, but it's hardly ever there, is the unfortunate reality. But a good application is going to log these kind of things. The main thing is going to be invalid input. It's basically if web application developers spend a lot of time dealing with input validation, and you're basically detecting cross-site scripting and SQL injection type attacks. So anytime that those rules are violated, that someone's trying to do something they shouldn't, and that should be logged. And then also just other kind of things, failed authentications, which could be, password brute forcing. Any sort of authorization and session type issues should also be logged. So basically, whenever there's any sort of error within the application logic, that should get written off somewhere. And other, critical stuff, just even successful things within the application logic may want to be logged. So that's a quick kind of what it should be. And this is just the kind of data that you want to record for it if you can. That's pretty self-explanatory. And if there are any developers here, there are some great logging frameworks available that really make logging very simple. Because a lot of times the reason that it doesn't get built into applications is because it's a lot of work to write it all from scratch, and it's hard to get it consistent and all that. But use Log4j or Log4net or Log4PL SQL or one of the other kind of things that are listed there. It really makes it easy to build your logging into your application and also configure it on the fly, that while the application is running, you can actually change the level of logging that's being done. So when you think there's an incident, you ratchet the logging up. But then when it's running normally, then you can ratchet it back down. So that's pretty cool. And now we kind of just get to the end. So we've gotten to the point where we've basically kind of traversed back through our application, starting at the web server back to the actual application itself. And now hopefully we know what happened. We have some idea of how the attacker came in, what kind of data they may have taken, that kind of thing. So now we want to know really what are we going to do about it. So I guess really the first decision is, we started this talk talking about the regular incident response and forensics processes, and there may be occasions when in a web application attack you need to go back to those, that once you've done all these application level things and you realize, hey, I can see that he attacked the Microsoft SQL server database, and then he used XP command shell to then run these other processes within the operating system. Well, now you're back to more of a traditional incident response methodology where you need to be looking for hidden processes or other extraneous processes that are running, network ports that are open, all that kind of stuff. So that's definitely a decision to be made. And then you also want to kind of just decide how you're going to fix it. You've got this problem. Now you want to, well, if you've got enough data to know exactly what happened, then you may be able to just kind of basically back out the changes that were made by the attacker in the database, if there were any, and kind of basically get back running from where you are. In many cases, you're going to have to go back to a backup and restore from that, and then try to pull over the legitimate transactions from the newer system. And sometimes you've got to just rebuild the whole thing from scratch, which is no fun, but sometimes it's just what you got to do, especially if you don't know how long the intrusion has been in there. A lot of times your backup tapes might be corrupted.
Right, and also sometimes you'll run into applications which are, for example, partly classic ASP and the rest of it is ASP.NET. And you have all the classic ASP stuff vulnerable to things which are by default taken care of by ASP.NET for the most part. So that's when it's time to call the shots and move everything over to .NET probably.
And obviously, if you're restoring from backup or building from scratch, you want to make sure you fix whatever vulnerability the application had before you put it online. Otherwise, you're going to be back right where you started. So I think that's obvious. But yeah, go ahead.
You should think about this stuff before there's an incident.
Oh, definitely.
Clean this stuff up when there's big prices going up.
Oh, definitely, definitely. I mean, unfortunately, you know, we do get called in to do application security assessments and that kind of thing where we do that. But typically, by the time we get involved, it's kind of too late. But yeah, there's definitely a lot of things you can do in the building of and fielding of the application to make it much easier on the people that are going to respond if there is an incident. I think Rohit and I were talking earlier. It's kind of the old saying: if you fail to plan, you plan to fail. You know, or you need to plan what's going to happen if there is an incident, so that you've got the stuff in place.
It's a typical military statement coming from a guy like that. You know, fail to plan, plan to fail. Or I heard another one:
Yes.
Your 50% operational capability or something of that sort. But I guess what Chuck is trying to put across is exactly the point the gentleman said there, is you want to think about these things well in advance. It's not after the fact. These should be incorporated into your SDLC, the logging, thinking about potential forensics, because you know, you can do everything right, just the one hole is what an attacker needs.
Yep.
So
And really, just this kind of just talked about what we were talking about earlier. That, you know, you need to be familiar with how applications work and how to update your checklists and that. I see everyone leaving, just remember we've got something to give away. So hopefully, whoever we draw is here, because you must be present to win. We should have mentioned that earlier. So anyway, in conclusion, there's really nothing else. So this is us, as we mentioned earlier. Thank you.